Recording on this computer. Okay, so whiteboard meeting 6 is now open. You were all, so I'm going to share my screen so that we can all be looking at the same screens at the same time. Let's see, I want to use this one. Thank you. So let's see, let's do that. Let's look at, let's start with room 3. Dak, Natalia, and Elliot, what do you guys think? What is your claim, and how do you support it?
We think that the ball is slowing down because, as you can see, the displacements over time are getting smaller, and we think that's because the ball is slowing down due to friction on the ground, and the X curve is flattening out on the ground.
Okay. Anything that anybody in the group wants to add to this? Any questions from the rest of the audience about this one? Okay. Room 4. Harry and Vincent. Yes. What say you?
So we thought the ball was slowing down because the displacements are getting smaller over time.
Mm-hmm.
Yeah.
Harry, anything you want to
add? Well, I mean, I guess you could, we have the same thought. I guess you could just show this by like the graph. You can see the curve and in the data. It also shows that it is slowing down.
Cool. Yeah, absolutely. So 2 examples of things slowing down, right? And now a little bit more interesting. So what about room 5? Marlo and Timothy, and now I guess now also Lucian. Should add Lucian's. So what do you guys think? What do you say?
We said the object sped up and then slowed down because in the beginning of the graph, the slope became more vertical, and then later it flattened out, which meant it slowed down.
Mm-hmm. Marika, we had that exact conversation earlier during the quiz. What do you think about that statement that Timothy made? Timothy said at the beginning it was steeper, so it sped up, and then at the end it was slower, so it slowed down. So it sped up and then slowed down. What do you think?
I don't know. I kind of talked to you like on Monday.
What's that?
I don't know. I'm not so sure.
Not so sure? What do you guys think? Did it speed up and then slow down? Did it always speed up? Did it always slow down? Did it slow down and then speed up? Tara, what do you think? Tara flashed her hand for a second.
I think it's at a constant.
Ooh, constant. Why?
Well, I don't see the dots exactly, but they look pretty close together, but they look like about the same distance from each other. I mean, it probably, if I zoomed in closer, you could see they were or not, but from the looks of it here, you can kind of see.
Okay. What do you guys, what is the cost? Yeah, Natalia.
I think it's slowing down because if you notice for each grid, where 2 lines meet, the first diagonal grids, I don't know if that makes sense, but they're kind of in the corner, but on the last one it's lower, so I think it's slowing down.
Okay, so we have so Tara saying I think it's going at a constant velocity, and then we have Natalia who's saying I think it's slowing down, and then there's Timothy who said it was speeding up and then slowing down. So we have a disagreement, which is perfect. This is exactly why whiteboard meetings were invented, to have a disagreement. So we need to have consensus at the end. Like, what do you guys think? Molly.
Well, I think that the person who said it's maintaining constant speed is mostly right, except at the end, you can see that it's going down like a tiny bit. So I think that it is going down at the end, slowing down at the end.
So you think it's slowing down the end. Do you think it was ever going at a constant velocity, or do you think it was slowing down the entire time?
No, I think that it was going at a constant velocity at some point.
Why? Why do you say that?
Well,
I'm not
it's
saying
like,
you're not right. I'm just wondering
Yeah.
what's your evidence for that?
it's like a straight line up until about maybe halfway between 1 and 1.5.
So you're saying it's a okay, so it's a straight line all the way to about the middle between 1 and 1.5, and therefore during the straight line it was constant velocity, and after that it slowed down. Interesting. What do you guys think about that? Timothy, you had your hand up also.
Well, I just want to know, like, do we include the acceleration part, or should we just not include the acceleration part?
Interesting. Okay, so let's talk about this. Was this ever accelerating?
Yeah, at the beginning, like when my hand pushed the ball.
So I would argue if you look at the dots, if you look at the first 3 dots, right? If you look at the first 3 dots, they kind of go like this, like literally the first 3 dots, right? But after the first 3 dots, it's all going this way, which means it's all slowing down, right? I would not look at this and say it was speeding up and then slowing down. Like I would look at this, I would say it is uniformly slowing down. You can see it's curved, right? I agree with you. It looks sort of straight-ish, but if you look at the overall pattern, like the overall pattern looks like it's kind of curved, going downward, right? Well, not going downward, like curved towards the bottom, which means it was steeper at the beginning and slower and less steep at the end. So it looks like the displacements are getting smaller. I agree with Natalia's observation that if you look at the between 0 and 0.5, 0.5 and 1, it looks like it's almost going like a full quadrant, right? But then between 1 and 1.5, it's definitely slowing down, and between 1.5 and 2, it's definitely slowing down. So it's interesting. This is one of those cases where it's on the cusp between, like, I don't think I would say that's as a whole that's a straight line, right? So let's see if we can find a straight line. So there was one that definitely had a straighter line. So let's look at this one. Ollie, Tara, and Vivian, what do you guys have to say?
So just by looking at the graph, we thought it was slowing down. But then if you look at the actual photo, there's not a noticeable like difference in the dots. So we were a little lost, but in the end, we just thought because of the graph that it might have been slowing down.
Okay. What did the rest of the group think?
I looked at the table, even though it was like super hard to read because it was microscopic. But
Shade.
the
Yeah.
I thought that the tennis, I'm pretty sure we determined that the tennis ball was slowing down because the velocity lowers as the time increases, which means it's not going as fast.
Oh, so you actually went and you went and looked at the velocity values directly. Smart. Interesting. Yeah, you could look at the velocity values, and so interesting. If you had like this, if you had a data table with like 30 velocity values, what kind of graph would you make to see if it's all one velocity or different velocities? What kind of graph could we make? Yeah, Vivi?
Make a line graph.
We could make a line graph, right? What else have we done in the past to see if there's one value or several values?
Histogram.
Yeah, we could make a histogram, right? We could make a histogram and see like one hump, then it's probably one value. If we see like a flat line or many humps, then it's probably different values. That looks to me, I don't know, like, is it just wishful thinking? I think Vivian, or is it Molly? I can't remember. One of the two described this as cognitive bias. Who said that? Was Molly or Vivian? Molly. Who talked about cognitive bias in her capstone. Like, do I want to see it as a flat line? Like, to me, that the red line, the red dots, they look kind of in a straight line. Like, you know, I don't know. Is it me? So, and then let's see, we have one more, which is this one. So this is the Tia, Marika, and Molly, right? Plus my doodles. So ladies, take it away.
So we have two, but I'm gonna explain the one on the right, which is mine. We found that for every 1 second, it'll move one. I don't know. I forgot what that measurement is, but it'll move one over or something. I can't see it right now, but so we found that like by using rise over run, which I completely forgot the last time or a few minutes ago. So we did rise over run for mine, and we found that it's moving at a constant velocity of 1 second per one something. Yeah.
It's a meter, right? It's a meter. The unit is a meter.
Okay.
Okay, so does that make sense? Any questions about this? Cool. I am going to stop sharing this. I am going to stop recording